Good afternoon, everyone. Today we will see section 7.6.2 of integrals theory. So today we will integrate some special types of integrand. Like we at first we see how we can integrate of type square root under x square minus a square dx. Then we see how we can integrate square root under x square plus a square dx. And at last we see the special type of the form square root under a square minus x square dx, and then do some example on this special type. Okay, so we discuss some special types of standard integral based on the technique of integration by parts. That means we use integration by parts method to integrate these special types. When we integrate, the formula of integration of root under x square minus a square dx is x by 2 root under x square minus a square minus a square by 2 log mod x plus root under x square minus a square plus c. Okay, and the formula for square root under x square plus a square dx is equal to x by 2 root under x square plus a square plus a square by 2 log x plus root under x square plus a square plus c. We can see the difference between these both formula is only with the negative sign. In the first, there is x by 2 root under x square minus a square, and in the second formula, the first term is x by 2 root under x square plus a square, and that is same as the value of integrand. Okay, and then in the first term there is minus, and then in the second formula there is plus, and then same a square by 2 log mod x plus root under x square minus a square, and the second term under root square x square plus a square plus c. Okay, by this way we can remember this formula. And the third special type, that is integration of root under a square minus x square dx, is different from other two, that is x by 2 root under a square minus x square plus a square by 2 sine inverse x by a plus c. We can remember this formula by using the concept of differentiation of sine inverse. When we differentiate sine inverse, we get 1 by root under 1 minus x square. So we can put in place of 1 we taken as a. So when we integrate root under a square minus x square, there must be a term involving sine. That's how we can differentiate the formula of third one. Okay, or we can remember by this trick. So the formula of integration of root under a square minus x square dx is x by 2 root under a square minus x square plus a square by 2 sine inverse x by a plus constant of integration. Let's derive this formula. How we get this formula? Okay, so we use the technique of integration by parts. Okay, we need to show that integration of root under x square minus a square dx is x by 2 root under x square minus a square minus a square by 2 log mod x plus root under x square minus a square plus c. So using the integration by parts formula. So what is the formula of by parts? That is, whenever we integrate the multiple of two function, here the function are fx and gx. So when we integrate fx into gx, the formula is fx into integration of gx dx minus integration of block differentiation of fx into integration of gx dx. Okay, so at first we have to recognize which function we should taken as fx and gx. Okay. So we have to integrate. Let I is equal to integration of root under x square minus a square dx. To apply integration by parts, we need to identify fx and gx. So clearly we take fx as root under x square minus a square and gx as 1. Why? Because when we see the integration by parts formula, in the formula we have to integrate the function gx and differentiate the function fx, as we have to find the integration of function fx. So we cannot take x square minus a square as gx. Okay, so we take fx is equal to root under x square minus a square as fx and 1 as a gx. Okay, so to use the integration by parts formula, at first we have to find the value of differentiation of fx and integration of gx. So when we differentiate fx with respect to x, so f dash x is equal to d by dx under square root x square minus a square. Now how we can differentiate it? We apply the chain rule of differentiation. What is chain rule? According to chain rule, if we differentiate a function dx d by dx fx the power n, so the formula is n into fx the power n minus 1 into differentiation of fx. Here the value of fx is x square minus a square and value of n is 1 by 2. So when we apply the chain rule, we get n, that is 1 by 2, into fx the power n minus 1, that is 1 by 2 minus 1, that is minus 1 by 2. So the square root comes in the denominator. So we get 1 by 2 into root under x square minus a square. Then by the chain rule, we differentiate fx. So d by dx fx is x square minus a square, and we know the differentiation of x square is 2x and differentiation of a square is, that is a constant, so it becomes 0. So we get 1 by 2 root under x square minus a square into 2x, that is x by root under x square minus a square. So now we calculate integration of gx. What is gx? The constant function. So when we integrate the constant function 1, so integration of 1 dx is x. So just substitute this into the integration by parts formula. Okay, so integration by parts formula is fx into integration of gx dx minus integration, then differentiation of fx, then integration of gx dx, and then integration of this whole block. Okay, so as the value of fx is root under x square minus a square and the value of integration of gx is x and differentiation of fx is x by root under x square minus a square and integration of gx is x. So just substitute this all value into the integration by parts formula and simplify. We get x into root under x square minus a square minus integration of x square by root under x square minus a square dx. Okay, so now we have to find the value of integration x square by root under x square minus a square dx. So to find the value of integration by parts, integration of x square by root under x square minus a square, we use the algebraic manipulation that we add a square and subtract a square so that we can separate into two terms. So we get integration of x square minus a square plus a square by root under x square minus a square dx. So now split the fraction into two parts. We can split now. So we get I is equal to x into root under x square minus a square minus integration of x square minus a square by root under x square minus a square plus a square by root under x square minus a square dx. In the first term of we can cancel out the square root under x square minus a square from the numerator and denominator. So we get x into root under x square minus a square minus integration of, we can write x square minus a square by root under x square minus a square as x root under x square minus a square ka whole square by root under x square minus a square. So we can cancel out and we get root under x square minus a square. So therefore I is equal to x into root under x square minus a square minus integration of root under x square minus a square dx minus a square integration of 1 by root under x square minus a square dx. Now in the second term there is integration of root under x square minus a square dx, and that is the question. We have to find the value of this integration and we consider it as I. So we can put in place of this just I. And for the third term, the integration of 1 by root under x square minus a square dx. So if we remember, this is a standard integration formula. This is a special case of a standard integration formula. We already integrate and we have the formula of this integration. So just substitute in place of second term, that is I. So we get 2i is equal to x into root under x square minus a square minus a square integration 1 by root under x square minus a square dx. And that is a standard case, and the integration of 1 by root under x square minus a square dx is log mod x plus root under x square minus a square. Okay, so if we remember the formula of integration of root under x square minus a square dx, that is x by 2 under square root x square minus a square by 2 log mod x plus root under x square minus a square. We also know the formula of 1 by root under x square minus a square dx, that is the second term of the formula of root under x square minus a square dx without a square by 2. So this is the trick. We can remember the formula of 1 by root under x square minus a square dx by the formula of under root x square minus a square, the second term without negative sign and without a square by 2, that is log mod x plus root under x square minus a square. Okay, therefore using this formula we get 2i is equal to x into root under x square minus a square minus a square. Just substitute the value of the integral 1 by root under x square minus a square, that is log mod x plus root under x square minus a square plus c dash. Okay, where c dash is a constant integration. Now divide the entire equation by 2 to get the expression for I. So I is equal to x by 2 root under x square minus a square minus a square by 2 log mod x plus root under x square minus a square plus c, where c is a new arbitrary constant and c is equal to c dash by 2. Okay, so we get the formula for integration of root under x square minus a square, that is x by 2 root under x square minus a square by 2 log mod x plus root under x square minus a square plus c. So if we remember this formula, we already know the formula for 1 by root under x square minus a square dx, that is second term without negative sign and without a square by 2. Okay. Now the second special case is integration of root under x square plus a square dx is x by 2 root under x square plus a square by 2 log mod x plus root under x square plus a square plus c. Okay. So again we use the by parts method to derive this formula. So why we need to derive this formula? If there is a question of the form, either is a first form, second form and third form, we don't need to apply this long process of by parts. If we remember this formula, we directly apply the formula. Not in the every case, every question we have to first find the fx, gx, then differentiate fx, integrate gx, and then put into the by parts formula to get the solution. We just remember this formula and find the value of x and a and substitute into this formula. We get the value of integral. Okay. So let's see how we derive this formula. So we need to show the formula of integration of root under x square plus a square dx is x by 2 root under x square plus a square by 2 log mod x plus root under x square plus a square plus constant of integration. Okay. So using the integration by parts formula, when we integrate fx into gx dx, we get fx, then integration of gx dx minus integration of block f dash x, that is differentiation of fx into integration of gx. Okay. So now let I is equal to integration of root under x square plus a square dx. To apply the integration by parts, we identify fx and gx. We can apply the Elite rule, or we can clearly see we have to take fx as x square root under x square plus a square and gx as 1, because we don't know the differentiation of fx until now. We have to calculate the differentiation of integration of root under x square plus a square. Okay. And so take fx is equal to root under x square plus a square and gx is equal to 1. Now we need to find differentiation of fx and integration of gx. So calculate f dash x. So to calculate f dash x, we differentiate function f with respect to x. So d by dx root under x square plus a square. Now we again apply the method of chain rule in differentiation, and here the function value is x square plus a square, and according to chain rule, differentiation of fx the power n is n into fx the power n minus 1 and then differentiation of fx. So d by dx root under x square plus a square is 1 by 2, that is n, into fx, that is x square plus a square power n minus 1, that is 1 by 2 minus 1, that is minus 1 by 2. So it comes to denominator and become 1 by 2 into root under x square plus a square into differentiation of fx, and that is d by dx x square plus a square, and differentiation is split into the summation. So, and we know the differentiation of constant term is 0, so differentiation of a square is 0 and differentiation of x square is 2x. So we get differentiation of f dash x as x by root under x square plus a square. Now we calculate integration of gx. Okay. So in gx is a constant function 1 and integration of 1 dx is x. So now we have the value of differentiation of fx and integration of gx. So just substitute this into the integration by parts formula. So formula is fx then integration of gx minus integration then differentiation of fx into integration of gx and then integration of whole block. So as the value of fx is root under x square plus a square, integration of gx is x, and differentiation of fx is x by root under x square plus a square, and integration of gx is x. So we get I is equal to x into root under x square plus a square minus integration of x square by root under x square plus a square dx. So now we use the manipulation such that we can integrate the integration x square by root under x square plus a square. At first we split into two terms such that it can be converted into a form which is a standard form. So we just add a square and subtract a square from numerator in the second term and split the integral into two parts. We get x into root under x square plus a square minus integration of x square plus a square by root under x square plus a square dx minus integration of a square by root under x square plus a square dx. Okay. Since x square plus a square by root under x square plus a square can be written as root under x square plus a square whole square by root under x square plus a square. So we get root under x square plus a square. So I become x into root under x square plus a square minus integration of root under x square plus a square dx plus a square integration of 1 by root under x square plus a square dx. Up since in the second term is again I, so in place of second term just take it as I. So I is equal to x into root under x square plus a square minus I plus a square integration of 1 by root under x square plus a square dx. And this is an special case. We know the formula of integration for this. That is integration of 1 by root under x square plus a square dx is log mod x plus root under x square plus a square plus constant of integration. Okay. And if we can relate this formula with the integration of root under x square plus a square, we can see this is the second term without a square by 2. So if we remember the formula of root under x square plus a square, we already know the formula for 1 by root under x square plus a square. That is second term without a square by 2. Substitute this back into our equation for 2i. 2i is equal to x into root under x square plus a square into log mod x plus root under x square plus a square plus constant of integration. Divide by 2 to solve for I. We get I is equal to x by 2 root under x square plus a square by 2 log mod x plus root under x square plus a square plus c double dash by 2. So consider it as new arbitrary constant, that is a capital C. Therefore, integration of x square plus a square dx is x by 2 into root under x square plus a square by 2 log mod x plus root under x square plus a square plus c. So to remember this formula, we can use the trick. The first term is x by 2 into same as the function of integrand, that is root under x square plus a square, then plus, then a square by 2, and the formula of 1 by root under x square plus a square, that is log mod x plus root under x square plus a square plus c. Okay, so in this formula there is only two terms, x and root under x square plus a square, that is used, and a square by 2 and log. Okay, so now we have the formula of integration of root under x square plus a square. So from now, if we have any question of integration of root under some polynomial, and if it is can be convertible or it is of the form x square plus a square, then we directly use this formula. We don't need to apply the long process of by parts. Now the third special case is integration of root under a square minus x square dx is equal to x by 2 integration of a square minus x square plus a square by 2 sin inverse x by a plus c. So we want to show that root under square root integration of square root a square minus a square dx is x by 2 into root under a square minus x square plus a square by 2 sin inverse x by a plus c. So let's consider it as I is equal to integration of root under a square minus x square dx. So to apply the given integration by parts formula, we identify fx and gx. So let fx is equal to root under a square minus x square and gx is equal to 1. Clearly we have to choose it as it in this way because we don't know the integration of fx. That is the question. We have to find the integration of root under a square minus x square. So now we find the differentiation of fx and integration of gx. So at first we differentiate fx with respect to x. So f dash x is equal to d by dx into under square root a square minus x square. So we apply the method of chain rule, that is differentiation of fx the power n is n into fx the power n minus 1 into differentiation of fx. So it become 1 by 2 into a square minus root under a square minus x square into differentiation of a square minus x square, that is minus 2x. So the differentiation of fx is minus x by root under a square minus x square. Now we integrate the function gx. The integration of 1 dx is x. So now substitute this into the integration by parts formula, that is I is equal to fx into integration of gx dx minus integration of differentiation of fx into integration of gx dx. So in place of fx we substitute root under a square minus x square and integration of gx is x. Then differentiation of fx is minus x by root under a square minus x square and then integration of gx, that is x into dx. So I is equal to x into root under a square minus x square minus integration of minus x square by root under a square minus x square dx. So I is equal to x into root under a square minus x square plus integration of x square by root under a square minus x square into dx. Now we have to find the value of integration x square by root under a square minus x square. We added and subtract a square in the numerator so that we can split into two terms. So it becomes x into root under a square minus x square plus integration of a square minus x square by root under a square minus x square dx. So I is equal to x into root under a square minus x square plus integration of a square by root under a square minus x square dx minus integration of a square minus x square by root under a square minus x square dx. So I become x into root under a square minus x square plus a square integration of 1 by root under a square minus x square dx minus integration of root under a square minus x square dx. Now the third part is I, since I is equal to integration of root under a square minus x square. So therefore I is equal to x into root under a square minus x square plus a square by a square root integral 1 by root under a square minus x square dx minus I. So it become 2I is equal to x into root under a square minus x square plus a square integration of 1 by root under a square minus x square dx. Okay. And we know the form, this is a special case, that is integration of 1 by root under a square minus x square, and we know the formula for this. So using the formula, integration of 1 by root under a square minus x square dx is sin inverse x by a plus constant of integration. And the same trick we used to remember this formula, that is the second term of the integration of root under a square minus ax square without the constant a square by 2, that is sin inverse x by a. Therefore 2I is equal to x into root under a square minus x square plus a square into sin inverse x by a plus constant of integration, that is c double dash, where c double dash is equal to a square by a square into c dash. Dividing both sides by 2 to solve for I. So I is equal to 1x by 2 into root under a square minus x square plus a square by 2 sin inverse x by a plus constant of integration, where c is a new arbitrary constant and c is equal to c double dash by 2. Therefore the integral value of integration of root under a square minus x square dx is x by 2 into root under a square minus x square plus a square by 2 sin inverse x by a plus c. So now we have another three special cases, that is integration of root under a square plus x square, then integration of x square minus a square, and integration of root under a square minus x square. Okay. And if we remember this three formula, we also remember the other three formula with division, that is integration of 1 by root under a square minus x square, integration of 1 by root under x square plus a square, and integration of 1 by root under x square minus a square. And to solve this type of problem where integration of root under any polynomial, so we try to convert into the form of these three and we directly apply this formula. So it is necessary to remember this formula to solve the problem without using by parts. Let's solve question example 1, example 23. Find integration of root under x square plus 2x plus 5. Okay. So it is not of the form we convert into the any in the form such that it can be recognized as any of the three cases. So we do this by using the completing square method. So x square plus 2x plus 5 can be written as x square plus 2x plus 4 plus 1. And we know x plus 1 whole square is x square plus 2x plus 1. So in place of x square plus 2x plus 1, we write x plus 1 whole square plus 4. So the polynomial x square plus 2x plus 5 is also can be written as x plus 1 whole square plus 4. So now we put x plus 1 is equal to y. We apply the substitution method. So when we differentiate x plus 1, we get dx is equal to dy. So my integral become integration of root under y square plus 2 square dy. And now this is a special form, special case, and the case is integration of root under x square plus a square. Here the value of x is y, okay, and the value of a is 2. So we using the formula of integration of root under x square plus a square dx, that is x by 2 into root under x square plus a square by 2 log mod x plus root under x square plus a square plus constant of integration. And in place of x, put y, and in place of a, just substitute 2. So we get y by 2 under square root y square plus 4 by 2 log mod y plus under square root y square plus 4 plus c. So substitute back y is equal to x plus 1, we get 1 by 2 in place of y, x plus 1, and in place of y square substitute x plus 1 whole square, and we know x plus 1 whole square plus 4 is x square plus 2x plus 5. So we get x plus 1 by 2 x square root under x square plus 2x plus 5 plus 2, that is 4 by 2 log mod x plus 1 plus root under x square plus 2x plus 5 plus constant of integration. So in this question, to integrate root under x square plus 2x plus 5, at first we use complete square method, so that the under square root it converted into a perfect square form plus any constant, so that it is of the form any of the three cases, and it converted to the case that is integration of root under x square plus a square. We write the formula and just substitute the value of x and a and get the value of integral. We don't need to apply the by parts method. Now we have to integrate integration of root under 3 minus 2x minus x square. So let I is equal to integration of root under 3 minus 2x minus x square dx is equal to. So at first this is not of the any of the form, so we try to convert by manipulation to algebraic manipulation to any of the three cases. So we use the complete square method. So for that we can write 3 minus 2x minus x square as 4 minus x plus 1 whole square, and x plus 1 whole square is x square plus 2x plus 2. So we split 3 as 4 plus 4 minus 1. Okay, so 4 minus 1, so it become 4 minus 1 minus 2x minus x square. So we get 4 minus x plus 1 whole square. Okay, so now we use the substitution method to put x plus 1 as y. So when we differentiate, we get dx is equal to dy. Now we convert the all integral of the with x to y. We get I is equal to integration of root under 4 minus y square dy, and 4 can be written as 2 square, so it become integration of root under 2 square minus y square, and it is of the form integration root under a square minus x square dx, and we know the formula for it, and that is x by 2 root under a square minus x square plus a square by 2 sine inverse x by a plus constant of integration. So just in place of a, substitute 2, and for x, y. So it becomes y by 2 under square root 4, that is 2 square minus y square plus 4 by 2 sine inverse y by 2 plus c. Substitute back y is equal to x plus 1. We get 1 by 2 x plus 1 under square root 4 minus x plus 1 whole square, and that is from above 3 minus 2x minus x square. So we get x plus 1 by 2 into root under 3 minus 2x minus x square plus 2 sine inverse x plus 1 by 2 plus c, and that is your answer. Okay. So today we see the three cases of standard cases of integral. We integrate by using the by parts formula. We find the formula for them, and from now we don't need to using the by parts method to integrate any such kind of problem which can be converted into that special case. We just need to remember this formula so that we can directly find the value of integral. Okay, thank you.